Today, the topic that we will discuss in this video is alternating series and ratio test. So what is alternating series? The convergence test we've worked with so far only work with positive term series, with the exception of geometric series where R can be negative, or the rare series with telescoping partial sums. Things get more complicated when the terms in a series can be positive or negative. The sequence S sub n of partial sums may not be monotonic, so it can be bounded but divergent. The alternating signs will be introduced in this topic. So ratio test, let the summation from infinity to n equals 1 a sub n be series with non-zero terms. Let 1 if 0 is less than or equal to p less than 1, then summation from infinity to n equals 1 a sub n converges absolutely. If p is greater than 1 or p equals infinity, then summation from infinity to n equals 1 a sub n diverges. If p equals 1, the test does not provide any information. So p equals limitation n to infinity a sub n plus 1 over a sub n. Example, for each of the following series, use the ratio test to determine whether the series converges or diverges. So A, from the ratio test, we can see that P equals limitation n approaches to infinity, and a2 raised to n plus 1 over n plus 1 over 2 raised to n divided by n equals limitation n approaches to infinity 2 raised to n plus 1 over n plus 1 times n over 2 raised to n. Since n plus 1 equals n plus 1 times n, p equals limitation n approaches to positive infinity 2 over n plus 1 equals 0. Since p is negative 1, the series converges. B, we can see that p equals limitation n approaches to infinity n plus 1 raised to n plus 1 divided by n plus 1 over n raised to n divided by n equals limitation n approaches to infinity n plus 1 raised to n plus 1 over n plus 1 times n over n raised to n equals limitation n approaches to infinity n plus 1 over n times element of n equals limitation n approaches to infinity 1 plus 1 over n times n equals e. Since p is greater than 1, the series diverges. So here's the activities. Determine whether the given alternating series is absolute convergent or divergent. 1. The summation of negative 1 raised to n plus 1, 1 over n. 2. The summation of negative 1 raised to n plus 1, n over n plus 1. 3. The summation of negative 1 raised to n plus 1, 1 over n square root of 3.